Alright, so let's take on more examples of partial fractions where the denominators have quadratic factors. So we have 6 minus x divided by 1 minus x times 4 plus x squared. Okay, so notice that I have a linear factor and a quadratic factor that I cannot factorize actually. So I'll write this as a divided by the linear factor, which is 1 minus x. For the quadratic factor, like we've done in the previous example, I'll write bx plus c divided by 4 plus x squared. I've got to write bx plus c because I need 3 coefficients here, right? 3 unknowns. So there we go. We have 6 minus x equivalent to a. So okay, I should indicate this 1 minus x into 4 plus x squared. So the LCM here is going to be 1 minus x, 1 minus x, alright, into 4 plus x squared. So I have a times 4 plus x squared plus bx plus c. All this is multiplied by 1 minus x, alright. So this denominator and this cancel out. Have 6 minus x equals a into 4 plus x squared plus bx plus c into 1 minus x. That's good. So let me choose some nice value of x here. Alright, let's choose a nice value of x here, like x equals, so what value of x would you choose? Let's choose x equals 1. Yes, that's a nice one because it's going to make the whole of this part 0. Oops. So that's going to be 5 equals, wait a moment, this must be equivalent, not equals. Okay, so 5 equals, what do we have here? A into 4 plus 1, which is 5. So you can actually see that a is equal to 1. Okay, good. Let's choose another value of x. Let's choose 0 because that's going to make this part, this b to be 0. So what do we have on the left hand side? We have 6 equals, okay, so if we put 0 here, we'll actually have 4a plus, this is c into 1, right? But I know what a is. A is actually 1, so 6 equals 4 plus c, so c equals 2, right? So now that we have a and c, I can just choose any value of x to put in because I already have 2 of the values. So let me choose x. Oops, let me choose x equals 2. Alright, so if we put 2 here, we'll have 4 on the left hand side. Then we'll have, if I put 2 here, that's 2 squared is 4. So that's 8a plus, alright, so if I put 2 here, that's going to be 2b plus c into negative 1, right? That's 1 minus 2. Okay, then I'll put in the value of a. So 4 equals 8 times 1, that's 8, plus 2b, alright, I should say minus, okay, so 2b, 2 times b plus c, and c is a 2. So there we go. So I have 4 equals 8 minus 2b minus 2. So 8 minus 2 is actually 6. Yeah, 6. So 4 minus 6, that's negative 2 equals negative 2b. Okay, negative 2 equals negative 2b. Just create more space here. Right there. So I have b equals a 1. Right, that's a nice one. So finally, my partial fractions are going to be a, which is 1 divided by 1 minus x plus bx, so that's just going to be an x plus c. C is a 2. All this divided by 4 plus x squared. Okay, that's a nice one. Let's go ahead and do one more example with the same category, a denominator with a quadratic factor. Alright, so let's do this. We have example 3, 4 divided by x plus 1 into this if you try to do some analysis, you actually notice that this one here cannot be factorized. If it can be factorized, then we just treat it as a linear factor after factorizing, but it actually can't. So let me go ahead and do this. I'll write 4 divided by x plus 1 into 2x squared plus x plus 3 equivalent to a divided by x plus 1 plus, so since this is a quadratic factor, for that I'll write bx plus c divided by 2x squared plus x plus 3. Alright, so I'll write this as 4 divided by x plus 1, 2x squared plus x plus 3 being equivalent to a into 2x squared plus x plus 3 plus bx plus c into x plus 1, all this divided by x plus 1 into 2x squared plus x plus 3. Alright, so the denominators will cancel out. I remain with 4 being equivalent to a into 2x squared plus x plus 3 plus bx plus c. Alright, all this into x plus 1. Okay, so let's choose some nice values of x here. What value would you choose? Let's choose -1, right? Because that will make all this to be 0. So I'll have 4 equals a into, so -1 squared, that's a 1. So we have 2 minus 1 plus 3. And then we have 4 equals 4a, which implies that a is 1. So we have the first value. Right, let's choose another value of x. We'll choose x equals to 0 because that makes this to be 0, which is good for us. So I'll have 4 equals a into, that's only 3, right, plus c into 1. But I know what the value of a is. A is 1, so 4 equals 3 plus c, and c equals 1. Good. One more value to go, so let's put any value of x of our choice because we already have 2 unknowns. So I'll put x as 2. So that gives us 4 equals a into, okay, so if we put 2 here, that's 2 squared is 4, 8. Okay, so I should say 8 plus 2. Is that right? Yeah, 8 plus 2 plus 3. Okay, plus, all right, so we have bx. Bx, that's 2b plus c. All of this multiplied by 3. That's 2 plus 1. All right, so we have 4 equals, I'll just create more space here. Okay, nice. So we have 4 equals 13a. 13a plus 3. Okay, 3 times 2b, I should say that's 6b plus 3c. I will now put the value of a and the value of c. So I'll have 4 equals 13a, which is just 13, plus 6b, I actually don't know what b is, plus 3c, that's just a 3. So 13 plus 3, that's 16. 4 minus 16, that's -12, equals 6b. Okay, so for that we have b equals -2. Alright, I will now write my partial fractions here. A is 1 divided by x plus 1 plus b, which is -2x. Okay, b is -2, and then plus c is 1, so I'll just write this as 1 minus 2x. That's the same, divided by 2x squared plus x plus 3. So there we go. In the next video, I will look at the third type of partial fractions where the denominator has repeated roots. So let's continue.